So in this video, we'll cover the qualitative analysis of group 2 cations. This is just introducing the group 2 cation, which are bismuth plus 3, copper plus 2, cadmium plus 2, and tin plus 4. We will start off with a solution of all 4 of those compounds, or not compounds, ions, and then we will start to separate them. But before we separate them, what we're going to do is we're actually going to precipitate all of these 4 out into a pellet. So they'll all be here, and from there we're going to draw out one component at a time, so that it will, in the supernatant, you'll have that particular metal. So for example, here all of the four cations are in the pellet, and then as soon as we add in potassium hydroxide, you'll see tin coming out into the supernatant rather than in the pellet. On the second time around, we take the rest of these guys, rest of the bismuth, cadmium, and copper. That will be in the pellet, but then as soon as we add HCl, the cadmium chloride is the one that's going to be in the supernatant. Then with the leftover copper sulfide and bismuth, we will put it in an acidic environment so that we can eventually separate the bismuth and the copper. So this is just an overall gist of what we'll do. Also, for each and every one of these guys that you take out, you will test them if indeed it contains that particular cation. So does this one really contain tin? And did this one really contain cadmium on the supernatant? So we will test those out. So in the very beginning, we will have we'll grab 15 drops of the unknown mixture that has bismuth, copper, cadmium, and tin. You'll take a test tube, and all of those mixtures will go into the test tube. So I have all of those 4 metals here, and they're going into a mixture here. Okay, now the mixture looks something like this. I wanted to show you an image. So you see this color, very light blue in color. Okay, and then afterwards you want to take a pH paper, and you want to make sure that this pH is also tested. So let me take out my pipette there, and then I'm going to grab a stirring rod, and I'm going to dip this solution in and then put it onto the pH paper. And this is a short range pH paper. You want this to be somewhere around like 0.5 or 0.3, and it's like bluish greenish in color. So I have that image over here. So this is the pH paper we're working with, and you want that to be somewhere around here, okay, 4 or 0.8, around that area. So you could see that right here. Okay, and then afterwards, say that this shows that this is too low, so meaning like it's too acidic, right? Then we need to add in some base. To add in base, we're just going to grab a base. We're actually going to dilute ammonia. So you will have a 6 molarity ammonia, and you need to dilute it to 0.5. So here's my ammonia. Okay, you take a few drops of ammonium, 6 molarity of ammonium, about 3 drops, and you place them in here. And then you'll take 36 drops of distilled water. So I have my distilled water right here. You have the distilled water bottle, and you put that in here. And you mix, and you take this, you'll get a pipette, and you will go ahead and drop this into this test tube, okay, drop by drop, so that once I retest with the blue litmus paper, the short range blue litmus paper, it will become somewhere around 0.5. It might be very acidic in the beginning. That's why I'm asking you to get a diluted base, right, ammonium, and then you will pour this in a little bit at a time, and then dip, and then test the pH until it goes to the right pH. Okay. All right, so let's put this off to the side. Then you're going to add 10 drops of thioacetamide. So that's something that you've seen a lot. So this doesn't smell very well, so smell very good. So you probably want to have a cork after. So thioacetamide is going in. So I represented it just as S because there is sulfur there. Then you're going to take this and you're going to put it in a boiling bath for 10 minutes. Let me take this out. And then here's my water bath, and you're going to put this into the water bath for about 10 minutes. And then make sure you clamp it with the the clothespin so that it doesn't wiggle around. And then afterwards, this is a new step that we haven't done before. We're going to run it with really cold water. So let's just pretend this is cold water, but you just use tap water and you run it through. Then you're going to add the dilute sample of NH3. Okay, you'll need this, and then you'll put like a drop. Okay, you just need a drop, and what's going to happen is you're going to be allowing these to precipitate out. Well, all of these will start to form into this. So the copper and sulfur will combine, cadmium and sulfur will combine, and these will also combine with sulfur. So let me put that on there. So here are all the precipitates. Now you're going to go ahead and take this, get another test tube, make sure it measured up with water, and so that you can centrifuge, right? Centrifuge requires it to spin down, and all of these precipitate will start to kind of clump up towards the bottom, and you'll be left with the supernatant. Then you're going to add in additional drops of thioacetamide, 5 additional drops, and more thioacetamide come in just to get more, see if you could get more precipitation. Then you will put this in boiling water bath again. I'll put this in boiling water bath. There we go. And then you're going to cool it under running of cold water. Then again, you're going to drop 1 drop of the NH3, the one you diluted. You're going to take this and you're going to place 1 drop. Here, I forgot to add this in. It's my 1 drop. Okay, and then allow it to mix. Okay, you're going to mix them all up. So yeah, the pellet is going to get disturbed, and that's okay because we're going to centrifuge it again. And whoops, there's my Pewsmith. And then you're going to get another sample of water that's going to level out as same as this. Then centrifuge this out, allowing all the precipitant to kind of clump up down here. Okay. Then you will take the supernatant that's here with your pipette. You will take out the supernatant here, and then that will discard. You will just discard everything that is left over. And to this guy, you're going to be adding ammonium chloride. So here's my ammonium chloride coming in, and then you're going to mix. So again, mixing this will break all of these up, okay? So that will be like this. But that's okay because we will get another sample of water and precipitate this out. Oh, that's my dog. And spin it, and all of the precipitate will be on the bottom now. The rest of the content that in here in the supernatant, you can take it out with the pipette and then discard. Okay,